Hello, everyone. Welcome to another technical stream for this Global Hack Week that's featuring API Week. My name is Jocelyn, and I'm here for the stream on API standards and protocols. I think we all got the chance to talk a little bit yesterday when I had the first part of my other stream, which was a little bit more kind of like a workshop because we got the chance to interact with tools like Fast API and NGRock. And honestly, I had a really nice time yesterday, and I hope we get to have a really nice time today as well. Yes, we are being live now. Hello to everyone, and also thank you for all your messages yesterday on the Discord about how you all liked the session. And well, stay tuned then for the part 2 of yesterday's session, which will be further on. Today we will be hosting this kind of like technical stream, but we will also have some spaces to see examples and real life scenarios where you would use all of these tools. And this will be just a one-time stream. So this is just like a part 1 and that's it. So we will be covering everything that you need to know as for today. As for how much code we will be doing, it will be a very short amount. This stream is mostly directed to hackers who want to learn about more of the in behind scenes about how APIs work, and more of like the different protocols that are out there for you to explore. And by the time that I was actually preparing the content for this stream, I actually learned like new things when I was doing the slides. So it also helped me. Um, and I thought that I knew at least all of the things that there is to know about APIs, but no one can ever stop learning with what you can find online. I sent the link on the chat for you to check in. Don't forget to check in because in that link you will get your points for the weekend, and it's a way of us knowing which streams you assisted and if you were present during the session and so on for you to get points and eventually some really nice swag. Awesome. So let's get started. And I think I haven't introduced myself, so let me just go super quick with that. So, some of you already know me. I'm a coach here at Major League Hacking, and I also enjoy doing streams. I would say my favorite types of streams are those who are either cloud APIs, AI and machine learning. I really enjoy those ones. And I hope we get something related to hardware because I also like hardware so much. I study robotics. That's also another fun fact. It's been very intense lately with all of the schoolwork and projects that we have to do. We have to code like in assembly language and really low level C code, which is it's very hard, and it will be fun to have a stream related to that as well. Another things, I also collect Minecraft bee plushies, which I love very much, and I brought one today, which is this one, and it's big. Oh, wait, there it is. It's very small. I have bigger ones that are kind of like this, which are the ones that I use like for sleeping or like for trips. But this one is just like the perfect size for me to take like to a hackathon um event or even like for traveling. It's also super fun, and I also have like the little wolf from Minecraft. And I really like how the movie has been generating like a lot of merch about this video game. So that's very nice. Yes, I have even more giant bees. I even have like, for example, these ones are the ones that I have like in my how do you call it? Like on my desk, I have like a crochet bee that it's been like super chunky and like super big. But those ones are not like for taking like any like to random places because they're like super big. What else? I am also a GitHub campus expert, so you can also ask me about the program or things as well. I was also a previous MLH fellow, so I went through the fellowship myself. I also get a lot of hackers asking me about my experience. So if you are one of those hackers who want to apply, for the summer. You can also ask me anything that you like about my experience or how was it during the fellowship as well. Great. So I hope we are all prepared because we will be getting started now on kind of like the lay down of what are we going to be doing today. We have a question here. Should one prefer using mechanical keyboard over normal laptop keyboard? 100% yes, if you have like the space to do so. Because, for example, right now, instead of me using, for example, I have a keyboard over here, which is the one that I use when I'm like in my house, but it's like super big because it's like complete keyboard. And usually, like, I don't carry that one with me because it's like it's big and it's heavy, so I don't take that one with me. Rather, I take one that it's kind of like 75%, which is smaller, and it's also Bluetooth, so I don't have to be carrying like the cable. And also, I would say I don't enjoy using my laptop keyboard, at least on the computer that I'm using right now, which is a new one that I just have, which is the Rock Zephyrus, and I love the 16-inch screen. So that was a nice treat that I did for myself because I was like, oh, I think I need a new computer, and then I purchased that one, which is awesome. I prefer mechanical keyboards. Yes, I think well, I wouldn't say everyone, but at least the majority of hackers prefer mechanical keyboards. Even when like you go to hackathons, like you see hackers like carry their keyboards or even like super large monitors. I mean, if the hackathon was in my city, because I've been to hackathons like in my city, um like I carry my monitor to hacking there. But if I was traveling, I wouldn't carry my monitor. And there's like hackers that do that, and that just like surprises me every time, like all of the commitment that they have. Yes, I also like the sound of it. For example, this one, I wouldn't say this one's like the best keys. This one's it's a racer, and it's like, I mean, it's like super, super clicky because it's like I think it's like green switches that Razer has. And then I have another one that it's a NuFi or NuFi. I don't know how it's pronounced. And it's also, it has like white and pink. And the sound of the keycaps, it's like bubbly. And I love that sound. It's very relaxing when I'm working as well. Great. Then perhaps some other time I will show you my other keyboards as well. But for the meantime, I only have this one, which I'm not currently using. So yes. Hey Jocelyn, this is my first time that I'm attending a Global Hack Week event. Hope it's going to be amazing. That's super great. You're just in time because we are getting started. And also throughout the weekend, we will have more streams and more workshops coming up. So if you want to, learn about everything that's going on during the weekend, let me actually share the schedule with you. Because in there you can actually see like all of the workshops that go on and where to register, and you can see them on your time zone, which is also super helpful. Where are you from? Okay, I will ask the chat if you can guess where am I from. I will let the chat guess where I am from. People who already know me, they will probably know where I am from. So if you already know, like let's see what everyone thinks where I am from. You said something about checking. How do I make sure I am getting points? So once you go on the link over there that I sent over on the chat, which is this one over here that says events.mlh.io, that one you will click on there, and then you will have, perhaps if it's your first time, you will have to sign up and then like verify your email, and then you can click on check-in. And then after that, you will receive an email each day saying the points that you have like during the whole weekend. So if you check in, then you should receive an email that you're already registered like for the stream, and then another one saying the points that you have. But the one of the points is only like once a day, and I think it's like in the morning when it arrives. No, I'm not from UK. Actually, Quinn is the one that has like the English accent, which I've done some paired streams with him as well. Nope, not LA. Yes, I mean you already know me, so that's why I sometimes talk about Mexico and like all of the cool things that we have in here. No, but close. I mean, I'm still Latin American. US, nope. Canada, no. But I really enjoy going to Canada, and they send me a lot to Canadian events. So, yes, so I'm from Mexico. I live near the US border. So it's a city called Monterrey, which is like in the border of like Texas and Mexico, which is very cool. Yeah, no worries. Okay, well, let's get started. And I love the side talk. So if you have more side topics to talk about, I will love to talk about those as well. So for today, we are going to learn about what is an API and some basics of it. um, I think yesterday's session and also throughout the weekend, we've all learned about what REST APIs are. So I would say that one is like the most common one. Then we have another thing called GraphQL. Then we have WebSockets and gRPCs. So my goal today is that you will be able to understand all the technical concepts behind how APIs work. And I know most developers or most people who are into the tech world, they usually use like REST APIs, which are kind of like the most standard protocol. So that's why I decided to make this technical stream so we can know that there's not just like REST APIs. There are more things that you need to know that actually work into backend systems that are more complex architectures to learn from, which will be helpful for you, hopefully on your career as well. Can we have access to previous sessions, because I like to go back to refresh what it's being taught? Yes, so on the YouTube channel you will be able to find, and I think Quattro Sinchis already shared the link. So yes, on the YouTube channel, all of the recordings of the live streams are uploaded once the stream ends. So in there you will be able to find even like the streams about super past sessions for Global Hack Weeks as well. Yes, these ones will be also available on YouTube. Is there a way to visit the slides later? Yes, I always share the content that I prepare for you during the stream, because if I prepare the content for you, then you should be able to access that content. um I always share like a GitHub link where I paste like the code and all of like the resources that I use during the stream. But as today's session, we will have kind of like a more explanatory and examples session. I will share the slides link by the end of the stream, and if I forget to do that, please remind me on the chat as well. Great. So let's get started with the definition of an API. I would not go super in depth with this because I think I have explained these like a lot of times, and also like the streams today are all about API. So you must have kind of like a notion about what it is. But in case this is your first stream and you're just getting started, don't worry, I got you. So APIs is basically the meaning for application programming interface. That's the meaning. And an API is just kind of like the middle person that connects two ends. So it's a software intermediary that allows two applications to talk to each other. So you have your API in the middle, and then you have one application, and then you have another application, and you want them to connect between each other. So how do you do that? You connect them through an API. So that's just like when you're working, I don't know, like building a dashboard, and on your dashboard, you want to visualize like the weather, like the Mexican weather. So to access that, you need to connect to an API that will give you the Mexican weather. And then through the API, you will get to display on your dashboard the information that is on that external tool. So that's just how it works. And there are different types of protocols that you can use for APIs, and we will be getting over the most important ones as for today. So I hope it's super clear about what an API is. And if it's not, we will be talking about this, while I continue during the stream. So no worries about that. So the first thing that we will cover is the REST API. So I would say this one is the most common one, and I placed the order of the protocols that we will be seeing, uh, kind of like the easiest one to hardest one. So this is the first one. So this should be like the easiest one, at least in my opinion. It can be different for more people, but at least that's what I've seen and what I've experienced. So REST API is the first one, and it is basically representational state transfer. So honestly, no one ever will ask you like, oh, what those rest means. I mean, just like the exact words, it's like super weird that someone will actually ask you that, perhaps in an interview, but they will be pushing a little bit too much. What you want to know is kind of like the meaning of what a REST API composes. So this is not a protocol that has to be clear, but a set of constraints. And what do I mean by constraints? So just basically to define several things that are hosted on web services that you should be able to structure. And this REST API is mostly used for web-based applications. So if, as I mentioned earlier, if you want a dashboard to display the weather of a country, then perhaps you will use a REST API to connect to a database and then fetch that weather data and display it on your dashboard. So in here, I place this image about what a REST API is. And honestly, the most common one that you will see are web applications, mobile applications. Yes, that could also work, and fetching data. Why? Because we sometimes have our database and we have our, I don't know, our app or our web page, and we want them to connect between each other without accessing like directly the database. So we use an API to kind of like standardize everything and connect all of the cables in between to make it actually work. So this is kind of like the architecture, and let's keep in mind that all of the concepts that we will be learning today have different architectures. So this is our first architecture of the REST API model. So as I mentioned, the REST API will be placed in the middle, which is kind of like what connects everything. And then you have our client, which in this case is kind of like the user that wants to access the information. And then we have the server over here. And the server is the one that processes the data that we actually need to display the information. And the REST API model, how it works is that you actually make a request and get a response. So over here, the user is making a request with the blue arrow, and then it's getting a response from the server through the green arrow. And for making a request, there are actually different types of standards that you need to follow. For example, using different HTTP methods, which are these ones that we have. This one in blue over here, that's the get method. And we have post, put, and delete, because that's how you want to access the data. If you just want to get a list of something, then you will use the get. If you want to add a new piece of information to your server, then you will use the post method, and then to update you will use put, and then to delete, well, delete. So you use those standards to make the request, and then the server will say like, oh, the client asked for a list of the weather in Mexico. So then that list will be returned into a response, and the response can be in different formats. The most common one is JSON format, but you can also access it throughout XML or HTML as well. So what needs to stick about what a REST API is that it works in a request response method. And the connection basically works is that you access a request and then you get a response right back, and then the connection is closed. So it's not like a constant connection. You just do request response and that's it. The connection is shut down, and that's just basically like the model of it. This is just like an example. As I mentioned on the previous slide, we get like the different methods for HTTPS that they are. So get, post, put, and delete. And over here, we can actually see a nice example of how they all work together. So the users or the clients can use different HTTP methods to interact with our data. And the data, it's the one that it's on a database. So if we go back to more talking a little bit more about backend development into interfacing with databases, then you should be familiar with the CRUD model, or at least what it means, which is basically create, read, update, and delete. And HTTP methods are kind of like a similar way of interacting with your database. As I mentioned, there are many of them. These ones are kind of like the most common ones. Let's say that you want to retrieve a list of books, then you will use the get method. Then if you want to create a new book, you will use the post method. And then if you want to update an existing book, you will use put. And if you want to delete a book, well, then you use the delete HTTP method. So there are different ones, and you will use each one of them depending on the use case that you want to have. And if you are seeing over here, you will access your API using different endpoints. And an endpoint is just basically like a slash and then like the address that you want to access, which is also something that it is written like on the documentation of the API. Or if you're building your own API, then you will be able to define that endpoint. So on yesterday's session that we had about Fast API and ngrok, where we were able to develop our first API endpoint, that's just how I defined it. So I basically created like a hello world endpoint, and I just placed it like slash and then like the main application. So it's super simple. All you need to know, it's kind of like the different HTTP methods that are out there, and that these methods will actually allow you to interface with your database, which in this case, that database could be like, I don't know, like it can be like a MongoDB database, an SQL database, I don't know, like whatever information that you want to access. And there are plenty of APIs out there as well. We will cover some in a second. So this is just how you will do an example of a GET request. So this is our basically following a request response model. And this is just an example about what will happen if you want to, I don't know, like grab some information from a social media platform. Then this is just like the general endpoint or the base URL. And then you have a slash users and slash 123. So perhaps in here, if you only do users, then you will get the list of all of the users in your social media platform. And then if you place the slash 123, then perhaps you will get only the user that has a name of 123. Because if we go back and you will see what's like under like inside the keys, that is just like a query parameter in order to get a specific book with the ID that you have. So this is just an example of a GET endpoint. And then we have some other examples, such as the Google Maps API in case you want to get like an address, or also kind of like a new one, like the ChatGPT API, which is for getting like responses. And we can actually go and see it working on my dashboard as well if we have some time. There's also the PayPal API. And these are just like 3 examples. Honestly, there are tons of APIs out there, and the majority of APIs follow the REST API model or architecture, which is this one. You have the client, you have your REST API, and then you have the data or server that you want to access, and it follows a request response method. So keep in mind, REST API is a request response method, and your API will be placed kind of like in the middle of it. So now we will go ahead and try an example on Postman. So before we go over there and follow along, Postman is just basically a tool that allows you to test APIs. So in case you want to know if your API is working, or you want to test someone else's API, the tool that you will use is Postman. There are other tools that you can use, but Postman is kind of like the standard. I mean, a lot of people out there use Postman, and I actually remember learning about Postman when I was kind of like young, and then I saw like the dashboard, and I was super confused about how it even worked. But well, today we will be able to cover a simple example. So I will share that link that it's on the slides over here, so you can also access it as well. And let me actually share my screen with the Postman open. So let me go ahead and do that now. So we are here right now, and let me open a new tab where I will have the Postman API. So let me paste this one over here. And yes, I like the Octocat very, very much. I even have like a plushie of the Octocat, which is also it's also super nice. A lot of GitHub swag. Awesome. So if you enter the link that I sent over on the chat, you should be able to be seeing exactly the same thing that I'm visualizing right now. So something that you need to do before actually trying out the things that we will be using over here, you need to sign in over here. So just try to sign in so you can try and run the methods that I will be running on stream. I will give you like 2 minutes for you to do that, and then I will go on and start testing some of them. Some moments. I'm actually surprised most of you didn't realize I was from Mexico, or at least like from like a Latin American country. Because I would say I have like a lot of Latin aspects, at least like on my not so good English as well. Great. So I think we are good to continue. I hope you got the chance to sign in into the Postman. Great. So over here, you will be able to see like the different collections that you can have. So we have status, books, user, and orders. So let's just go with the first one, which is status. And if you can see right now, this one has an HTTP method that is get, and then the endpoint is called get status. So let's click over there. And in here, you can actually select the HTTP method that you want to visualize. And then over here, as I mentioned, you will have your base URL. So it's just basically kind of like the URL of the API that you want to access. So for this example, is this one, simplebooksapi.glitchme, and then the endpoint is slash status. So we can actually go ahead and send this request. And once I sent my request, I am getting my response. So the response is being returned in a JSON format, and it says, okay, status is okay, everything is good. And then we have also our response code, which is 200. And this one basically means that the request was successful. So there are actually different error numbers or error codes that you will get. And I would say this is something that they will actually ask you on an interview. So for my current job, which is related to cloud and testing, they asked me a lot about APIs. And I remember some of the questions was like, oh, like what does 500 mean, or what does 404 mean? Or like the response error messages that you get when you are actually sending like a request to an API. And I was like, oh, I had to remember all of those. So 200 basically means a request successful, and it is also in green, so you know it's something good, and we actually got the response over here, so everything's fine. Then let's go ahead and try another one, which is get list of books. And this one also has the same base URL. And this is just basically stored in a variable, and that's called base URL. And this in here is the meaning of our variable. And then we have another endpoint that's called slash books. And if I go ahead and make my request, I will be getting again 200 OK because the request was successful. And then I'm getting all the list of books that are on my database, and that is returned in a JSON format. Then let's go ahead and see one that it's a bit more complicated. Let me find one that it's a post. There it is. So this one is to register a new user. And how this basically works is that on the body over here, once you do a post request, that basically means that you want to publish information into your database or your server. So you use this endpoint API clients, that is to create a new client on your database. And then you have to pass on a body over here saying like the stating like the JSON format that you define, which in this case it has a client email and then the client name. So if I send this, then I will be publishing the client name. Let's see, let's enter a value. So client name will be Jocelyn. And then, for example, client email will be, I don't know, Jocelyn at mlh.io. And then if I go ahead and send this, I will be able to publish this. So now, as you are seeing, we have a new response code, which is 201. And 201 basically means that the resource was created and inserted successfully in our server. Then as a response, and this is not always something that happens, but as a response, we also got an access token. So this is a question for the chat. What do you think access tokens or API keys are used for in REST APIs? And I will give some minutes for you to answer that question on the chat. So again, what do you think an access token is used for if we are accessing an API? So we have an answer here to access the API. Yes, that is also correct. To logging the user, if we want to sign in user that we added, yes, that could also be another example. Are they for authentication? Yes. So I think this one is a nice word that I would stick with, authentication. That is also true. For security purpose, I mean, kind of. For authorization for the client, yes, that is true. To make sure that the user is authorized to use the API. Yes, that is also correct. Oh my God, we have a lot of answers. I really like that. To access certain resources or perform actions on a server. Okay, yes, that's another side of seeing it. So basically, if we are using an access token or an API key, that's just like for either for us to access the resources that they are offering and also for them to monitor how we are using their API. So not all APIs are free, and some of them are actually charged per use. And in order for you to access their API, they will generate you like a key, just like this one. And it works, yes, as authentication, and it also works for them because they are basically charging you for the resources that you are using. So going back to the example of using the ChatGPT API, you need an access key, so an API key. And that API key, it costs money. So depending on how many requests you are making or how many tokens you are using on your questions, then that is what they basically going to charge you over there. Awesome. So let's go back and continue. So for now, we should all know what a REST API is. And this is just basically follows a request and response method. So that's a REST API. And we actually got a chance to do our own example on Postman, which is also a super, also a super nice tool that I'm pretty sure you will use it at least once in your developer life. Great. So moving on to the second one, and this one is a bit, I would say, a bit up more in complexity scale. So REST API is kind of like the plain one. It's kind of like a super easy to understand architecture. And then we are moving on to GraphQL, which is the second one. And GraphQL for query, this is actually a query language and runtime for APIs. How this works is that you will only be requesting the data that you need and not just like receiving fixed data, such as like on the REST API. So this tool was actually developed by Facebook back then, and it is also open source. In case you want to view the project online, you are free to do so. And it is also a flexible way to interact with APIs compared to the REST architecture. So you would see in a while why I meant by requesting only the data that you need, and rather than just getting fixed data, because this is kind of like the most different thing um, for like REST architecture. So this was actually developed by Facebook. It's not something that, it's not like the REST API that a lot of people like kind of use it. It's not like a company like just invented like REST architecture. And GraphQL, it's a bit more, it's like newer. So this is kind of like how it works. I know it might seem like a lot, but once you see the example, you will be like, oh, like this kind of like makes sense. So in here, we have several clients. So just as the REST architecture, you have your client, which is kind of like a user that is using like an iOS app, or like a web page, or like a desktop application. You know, you have different clients over here. Then you are basically performing your GraphQL query, which is in a specific query language format. And then that query goes into the GraphQL server and fetches only the data that you need. So using this query language, you are only fetching the data that you need using a GraphQL server. And you also get a response, kind of like a REST API, that you get a response. And that response is also on the format that you need. So if we go back and talking about REST APIs, on a REST API, you basically make a request, but the request is just like adding an endpoint, right? And that endpoint, it's like you are not defining the format of that endpoint, but the developer who created that API, he or she actually defined the format, and you're only accessing that endpoint that it's kind of like in a fixed format. And as a response, you are getting the response that they want you to have, not that you want to have. So kind of like a more code example. This is how it actually looks like. So this is a laydown of how a post example for publishing information into a GraphQL server will actually look like. So you declare your post in here, which is a type post, because we want to post new information. And you say like, okay, I want to fetch an ID, a title, a body, and an author. And then the author will be in another class, and each author, I want it to have an ID and a name. And then you define your query, and your query will basically include the post class over here and the author class as well over here. So I would leave you a while to look at this and try to see how it relates. I know the architecture, it's kind of complex just by looking at it for the first time. But once you see the example, which is basically this one, you will get to see like how easy and how helpful it is to understand in comparison to REST APIs. So this is our query at the end, which is kind of like query, and then we have like the post and the authors. And the post was declared over here, and the author was declared over here. Oh, I mean, kind of. I honestly never used TypeScript. I would say I'm afraid of TypeScript. I'm afraid of frameworks. Like, I remember, well, at least like I, as a developer, I started with kind of like the basics. And for me, my basic framework was Flutter framework from Google. And I remember I wouldn't do anything else that was like Flutter. So all my projects were like for Flutter framework and Dart language. And I was just like super try hard like on that language. But then I realized that it's just like a super specific framework, like literally not a lot of people or projects use. So that's when I realized like, okay, perhaps I don't like using frameworks that much. And that's when I moved on into only focusing on like backend systems. And that's where I am right now. And I would say I'm happy to be here, but I actually had to go through like the whole developer path of using and learning how to code. And I remember in those times, I mean, I'm not old. I'm 20, so I'm not like so old. But when I started coding, there was not like ChatGPT. So I remember spending like hours and hours like just to trying to fix something. And if that error was not like on Stack Overflow, then the only a chance that you had on solving that error was either asking someone that it's like super pro, or like posting your question in like a forum or like Reddit or like GitHub, and like praying that someone would actually see your question and like answer it. Yes, TypeScript is nice. I've seen a lot of people being super intense in doing like super cool dashboards on like web pages, and I just admire them and how can they do like super pretty stuff, and like with all of the animations and how it works, that just looks like super intense. Can we have type query posts? Can you explain the structure of it? So that would be in case that you want to do a query that is named query. I mean, you can do it, but it would not be very intuitive, because then when you actually do your query, it will also be named query. So I don't know if that would bounce you like an error for naming it like the same format. Where are these GraphQL APIs used? Yes, that is a good question, and we will see an example in a minute. Just hold on to that. I've never seen this structure before. Honestly, same. Like I've been I've been using APIs for so long, and I've never used GraphQL like in a professional um well, not in a professional, like in a random way, like just to make a project. I'm not like, oh, I'm going to use GraphQL, because I think I've never had the need to actually request for a specific information. Usually what we do is that we use a REST API, we request for information, and then the response that we get, we filter that information using, like, I don't know, like we caught a string, or like we only filter the information that we want, instead of actually defining it using GraphQL to only request the information that you actually want. And this will be that how we will be requesting the specific data. And then the important part is actually the response that we get. So on the response server, we return the exact shape with the data that we requested. So over here, if we go back, we have posts, and then inside posts, we have a title, and then we have an author, and that author has a name. And if we go over here, we have the posts, we have title, we have author, we have name, and then we have another one that's a title, author, name, and that could just go on and on. So now that we know about what GraphQL is and how it is compared with REST APIs, you might be wondering, they are kind of similar. Yes, they work in a similar request response format, but the key difference is that on GraphQL, you only request the information that you want in the format that you want, and you get a response in the shape that you want for your data. So this is helpful when you are working more professionally, perhaps working like in a personal project or like a school project or something that it's like kind of easy to implement. I wouldn't go through all the process of setting up a GraphQL server, but perhaps like big companies or people who actually manage like large chunks of data, they actually need their information to be structured in order to, well, save some processing costs or make it like more efficient. So GraphQL actually allows you to have the flexibility of molding the data in the format that you want, rather than just sticking to the format that you have with the REST API, which is something that you cannot actually change. Yeah, so you cannot change it unless you are like the developer who actually built that API. So yes, I mean GraphQL. Um, I've never done a project with this. I mean, I've seen examples and I've used examples, but I've never like actually did this by myself. So I wouldn't say um it is not like very common compared to REST APIs. So this is just like another comparison between REST APIs and GraphQL. So over here on the REST API, we have our GET request, which is requesting for a person. And then we have our request, which is a JSON that has first name, middle name, last name, email, and then a relationship status. And then on GraphQL, I want the same person, but then I only want to fetch the first name and last name. Give me a moment so I can close my door because it's being kind of noisy right now. Great, because it was like kind of windy on my window and my door was kind of like moving and it was making a super loud noise, but all good now. Okay, so going back, I think this is a super nice example to see comparison between them, because in this one, as you are seeing, I can only like request a person and get like all of the info back. But then on GraphQL, I can actually say like, oh, I only want to fetch the first name and last name, and then that would basically be like getting only like first name and last name from like your data over here. And as a developer, you might be thinking like, okay, I might get like this response and I might filter this on my backend as well. So yes, you can also do that. So that's why I'm saying these two are kind of like similar, depending on how much work you want to do when using like a REST API. So yes, great. So now we will basically see an example of how this is actually used. And for that, I would like us to go directly to the documentation for GraphQL, which might seem like a lot, but they have a nice example that we can actually understand super quickly without having like a lot of past experience on this. So I will share the link with you as well. And let's open a new tab for GraphQL. For this one, we will only be going through the docs and seeing the example that it's out there. We're not actually going to code this one because it will take us a while and we have some limited time. But we will actually see how it will work now seeing the directed documentation for GraphQL. So the first thing that you need is basically just defining the fields that you want for your data. In this case, this is just a GraphQL server that tells us that we want a user that has a name. Then we need a function for each field on each type. So we have query, and then we have user, and then just doing this. This is just kind of like like how they are doing it, but you don't actually have to specify it like this. This is just how they are doing like their example. And now I will perform the query with exactly the information that I need, just like on the example before with the person first name and last name. Now we are only requesting for me, and I want only my name. So now I will get the following JSON result, which will be data, and then inside the structure of me, and then my name. So this is just like a simple example, and they have like more options over here that you can actually use. Oh, do we actually get to try in here? Write email. Will that work? I mean, it says like the best way to learn GraphQL is to start writing queries. The query editors used throughout this guide are interactive, so try adding an ID. Oh, nice. And appears fields to the hero object. Let's see. Appears in. Oh, this is nice. Yes, so you can actually be learning on how to do like your queries over here, and that's nice that this is interactive. And if like I delete, I don't know, like name, perhaps I won't be able to get anything. Yes. Now piercing, I will delete that. Great. So this is nice and interactive to see how they actually do like the queries. But this is just similar to the request response format. The only difference is how you are actually doing and obtaining the information like that. When do we need to create APIs? Most of the time, they are available at various API platforms. Yes, that's it. That is actually a nice example that we covered yesterday on creating our own API. So I placed as an example a school project that I developed where I had to build like a model of a house, like an Internet of Things smart house, and on the model of the house, which was like a box with like different things, and on my house model, I had like different sensors, like temperature sensor, like proximity sensor, noise sensor, and so on. So those sensors published information into a database. And how I read information from that database was throughout an API that I created. So I created my custom API in order to connect the information on real time that I was getting from the sensors and display that information of the sensors on a nice dashboard. So I can actually share again that link, which is on my GitHub. I actually share it on the stream yesterday in case you want to see it more in depth on the YouTube channel. Let me just share this one super quick. And the API that I created it's over here. I think the dashboard is not live, but yes. But it is paid. It is better to create your own API. Yes, I mean most services or most APIs you need to purchase per usage. It's not very expensive. Most of them are like super cheap if you use it for personal use. But if you actually want to develop your own custom functions, then I would recommend for you to create your own as well. Great. So let's move on to the third topic, and we are moving quite fast on this. So the third one is WebSocket. I place this one as third place in complexity, as I mean the concept of WebSocket is kind of like simple to understand, but then like the architecture can be kind of like well, not the architecture, like the code implementation is much harder than using like GraphQL or like using a REST API. So a WebSocket, it's a communication protocol. So it's a actual protocol that it's out there that you can actually search and interact with. And a WebSocket allows you to have bidirectional communication over a connection throughout your server or the connection that you are up and running. And in the examples that we saw before, for example, on REST API and on GraphQL, those types of APIs are only one way. So you get a request and you get a response, and that's it. And on a WebSocket, you can actually leave the connection open. So you get perhaps one request and you get like two responses, and you are exchanging data simultaneously in a bidirectional format. So basically this is an example, like the REST API or HTTP is request response, but a WebSocket will allow you to receive that data asynchronously. So basically not in a request response, but more like over time connection. And there is no need to create like new connections each time. So for example, on the REST API, you need to actually open a new connection every time you make a new request and every time you get a new response. And for the WebSocket, that is not true. For the WebSocket, you leave the connection open, and then you get all of your information floating into your client or into your user. So some direct examples or applications of where WebSockets are used, and this is actually something that I've seen so many times. So WebSockets are actually out there so much. And they are mostly used for real-time web applications. For example, messaging applications, chat apps, for example, that require you to interact and having messages whenever you want. That's also like an example. And then Something trendy is like, for example, these AI agents that respond in real time, like the real time API, or while chatting, they're also using WebSockets. Because imagine having like your ChatGPT, that you are talking like to ChatGPT through like voice, like on the real time API, instead of just like doing a request and response, because that would take like more time, then you just use a WebSocket in order to receive data in an asynchronous manner instead of just like waiting. That's just like an example, and we will actually see it on the OpenAI dashboard in a while. So this is the architecture for WebSockets. You have your timeline over here that your server leaves the connection open, and the client can connect and receive back in no such order. So you can have like 2 requests and like 2 responses, or like 1 request and 5 responses. I don't know, depending on the usage that you are giving to your client. But the server always leaves the connection open over time. So these APIs are actually more hard to set up if you're working in a project environment and not a professional environment, because you need to set up like your server to receive data constantly, and they are usually expensive. So you perhaps need to hire or like purchase an AWS server that you will be using, and that will be costly, because sometimes AWS can be kind of like costly. So that's why it is harder to implement, I would say. But it has really, really nice use cases on real life scenarios. So this is a more detailed architecture compared to this one. So this one is for you to only understand that you leave the connection open over a period of time, and you get like the connections in not a specified order. They can be like super random, and you don't actually care because the connection is open and they can do like whatever they want to access and receive. And then this is actually a more structured way of how a WebSocket works. So you have your handshake, which is basically just you saying like, oh, like the connection was open, so that is successful. And then you have bidirectional messages, so it's open, and it is a persistent connection, so it won't close in order to you ask the server to close itself. So what will happen is that if one side closes the channel, then the connection will be closed. And that's just like, yes, because if it is bidirectional, if one side closes, then you will not be able to reach the other side. So like nothing will work and it will be closed. So this is a 3-step process. So you have your handshake for opening the connection. Then you have the messages that are incoming and returning in periods of time. And then the 3rd step will be like to close the connection. And that would happen if one party closes their connection on their end. Yes, so that is the architecture for the WebSocket. I wouldn't say it's like impossible to understand. I would say it's pretty straightforward if you would like to see it in examples of like messaging applications, or like those AI agents that I mentioned earlier as well. Those are also super helpful to have. So here are more examples, more targeted into real life. For example, feed on social media. Like if you open Instagram, you will be able to see the likes and comments on real time. So perhaps if I go on and post a new comment, then my friend will be able to see that comment on their feed as well. And that's just because their social media feed is connected in a WebSocket, which allows connection on both ends, so everyone can see what you're posting like on real time without the need for you to request that information. So imagine that you are using like Instagram, and you need to request to view the likes instead of just like seeing them like update on your screen. I mean, that would not be very fun or very intuitive to understand. And another example is the Google Docs, for example, which allows real-time collaboration editing. I know there are more tools for real-time collaboration, and Google Docs is one of those. And that is just basically that you are able to see what your other friend is writing on Google Docs in real time. And that is also a WebSocket that is also using WebSockets. So this is another nice diagram of WebSockets, a little bit more simple, that you have your client, you have your server, and then you have basically the data that it's being incoming over there. Great. So now we will see an example from the ChatGPT real-time API. So we're going to go to an API that actually uses WebSockets, and they will actually tell us how to set up the WebSocket in order to use it. So let me actually go ahead and share that with you all. Let me just find the link for that one. Give me a moment. I'm going to tell you that story time later on about the time that I tried to use the real-time API and I was not able to do so successfully. Let me share that with you. WebSockets. We have a question over here. I think I was missing that. So how is a WebSocket different from HTTP? So HTTP basically follows the request response method. So you request information and you get information. And a WebSocket is just like, I open a connection and you can do as much requests and responses that you want. And I don't care. Like the connection will be open as long as you want it to be open. And you're getting just all of the information coming in. And for the HTTP, you actually need to specify like, oh, I want to post information, I want to get information. And on WebSocket, you're just leaving like the connection open, and your client can basically interact in the way that it wants. So I'm opening the link that I actually shared with you, which is for the WebSockets in OpenAI. So let me make this screen bigger. Awesome, great. So this is an API that uses WebSockets. It's called Real Time, and it's from ChatGPT. So this one is kind of like their AI model that allows you to talk to ChatGPT via voice and get live responses. So this is a nice example of a WebSocket, and it says that you can use WebSockets, which is great for server-to-server applications from your backend of your building a voice agent over phone, for example. So let's go down and see the implementation of it. This is for WebRTC, but we will not be using that one. Here it is. So connect with WebSockets. So we have even a definition over here. WebSockets are a broadly supported API for real-time data transfer and a great choice for connecting to the OpenAI real-time API. So here is the architecture now applied into OpenAI. So you have your server using WebSocket, and you connect using an API token in order to use the OpenAI API. So then if we go down over here, you will be getting basically the query parameters that you will need in order to make the connection successful. So in here, they mentioned that we actually need an API token. So that will go inside the header, which is the viewer token over here, your API key. Then as a query parameter, we can pass on the model. So the model is either GPT-4o or, I don't know, whatever model ID that you want to connect to. GPT has different models, so you can choose the model that you want. And then we have our URL for connecting into our WebSocket, which is this one, which is kind of similar to the REST API, where you are defining your endpoint. And then this is an example. I will show the one in Python. So this is an example of connecting with WebSocket to Python. So we have our API key, then we have our URL where we are passing on our first query, which is the model GPT-4o. Let me make this bigger because I think it's too small. There it is. So we're passing on the model, which is GPT-4o. And then as a header, we're passing our authorization token. And then over here, we are opening the connection. Then depending on the message that we receive, we are basically passing on all of the parameters for our WebSocket application. And it basically says like run forever, because like it will be open as long as you want it to be open. And just as simple as that. And you can also do it like on browsers if you want to have like your real-time assistant like on a web browser. Then you can also run it like this, or like on Node.js. And it's like super easy. Like you just copy paste this and start running it, and you will be able to make it work. Great. So that's just an example about how WebSockets work. For this example, which is on the ChatGPT API. And as I mentioned, I tried using this API back then when I was making a real-time AI agent for phone calls. And I literally gave up because I was not able to set up the server correctly. But I think I was not very familiar about how to use WebSockets back then. But now actually seeing like some successful implementations, I was able to do the AI assistant, which I actually did a stream back then on AI Global Hack Week, where we basically built like a phone assistant. Like you basically called like a number on your phone, and then like an AI agent responded, and you could fetch like a lot of information from there. It was also a fun stream. Like a lot of hackers were able to build their own phone agent and call it like whenever they wanted. And the best part is that it was like free. So that was also something super nice to have. Great. So that's for WebSockets. And before moving on, we've seen three models right now, or three architectures, or three types of APIs. So we've seen REST API, which is basically you're using an HTTP method and you are requesting and getting a response. Then we have the GraphQL, which is similar to the REST API, but for the GraphQL, you can basically only request for the format and response of the information that you want to get. So you get to actually craft that. And then we've seen a WebSocket, which is basically to leave a connection open for real-time applications where you actually need the data to be updated asynchronously. Awesome. So now we are going to move on to our last API that we are going to be seeing. So this is in the scale of 4. So I would say this is the hardest one to understand. And this is super crazy. I just learned how to use this like 1 week ago. And I'm actually going to show you the code that I did for a real-time thing that I created for my robotics team. And I would say it was challenging to understand, but thankfully I had someone who have already used this before that explained how it's used. So now I will be able to explain it to you as well, now that I actually know how it's done. So gRPC, it stands for Remote Procedural Call, which is basically a protocol. If you go ahead and search it, you will be able to get more documentation on that as well. And this is useful for microservices, so applications or architecture that uses microservices on high scale applications, they are very likely to use gRPC because it is great for backend to backend communication. Like if you want to connect two backend sites, you will use RPC, which is kind of like an internal API between your services in order for them to communicate between each other. So gRPC is an open source framework as well, and this one was developed by Google, so that's why it's called G, like from Google. And this basically allows you to communicate between applications or microservices over a network. So I would say this is not very, very similar to the other APIs that we've seen, but you will see some similarities once you get to understand it a little bit in depth. And gRPC basically makes it easier for applications to interact within each other. So yes, I would say this is the hardest one to understand because it has a lot of technical details to go on. And how it works is that it basically you have a client that calls a function on a remote server, just like a local function, but this time it's a remote server that it's like on your computer perhaps. And then that server processes the request and executes the function and sends back the result. So you're basically having all your gRPC architecture on your own computer, and you're making your own computer like connect to different services that you are running. And I pasted a link over there that actually has a nice piece of documentation on Medium, which is a nice blog post that we can actually read in case you want to learn a little bit more about what it does. And I'm also going to open that as well. So we can try to go over that together. So yes, let me actually share the link that I've shared. So this is like a beginner's guide to gRPC, what it is, and why should you use it. So this is actually something that I've read, and it helped me a lot to understand what gRPC is, because it basically compares like the traditional REST API with gRPC. And it also explains to you like what REST is, and then it compares it with how it would look like in a gRPC server. And this is just kind of like the model of how it works. And the main difference is that your gRPC can basically follow like different communication patterns. So it can be one-to-one, like REST, like single request response, or you can have one-to-many, many-to-one, or many-to-many, which basically will mean that both client or servers send multiple messages in real time. So this one is the architecture of this one is more complex to understand, because it is like so there are so many things that gRPC supports that they can do like many more things that compared to the REST API as well. But yes, feel free to check that resource out for gRPC. It's nice sometimes to read these kinds of blogs that people write. So this is the architecture, and yes, try to see it. It has several steps, and it's more like of a workflow, because first you need to define a protobuf file, which is a specific file configuration type for this gRPC API. Then you need to run a command in your terminal, which is basically compile this file, and that file will generate two other configuration files. They are auto-generated with a command, with a terminal command, and then it will generate you code in the language that you want. And then you need to implement two things, your server and your client. So you will be able to write the code for your server by yourself, and also the code for your client, depending on the usage that you want to give it. So I would say gRPC is useful when you want to create an API that has like your specific server configuration architecture for your own service that you created. And I will also show you some examples so you can get more familiar with these things that I'm mentioning. So again, I would say this is kind of like a four-step process. So you define a configuration file that's called protobuf. Then you compile that file using a command on the terminal. Then that will generate you code, and then you will be able to implement it on your server and on your client code. So two different Python files, for example. So now let's go ahead and spend some fair amount of time seeing and diving into some examples. So firstly, we will go to the official gRPC example, and then we will move on to an example that I developed about 1 week ago. So let me actually share with you those things on the chat. So gRPC. There it is. So let me go ahead and open that myself as well. Awesome. There we go. So we will go through the documentation guide for gRPC. If one of the uses of gRPC is to connect backend to backend, will both backend applications have server and client? So depending on which services you want to implement, but no. So you basically you have your service, and your service can interact like with other services. But for the gRPC, you would only need like a server.py and a client.py in order to make all of the configurations in between them. Because on those files, you will actually specify how all of your services interact with each other. If you want to connect different backend to backend applications, then you can create another gRPC instance, which will be, for example, server 2 or server for messaging. I don't know, depending like on your use case. But if you only want one service to connect with a specific types of services, then you will only need to define one. But if you want like more implementations or more different configurations of the same application, then you can create multiple gRPC servers and clients. So you can basically configure it the way that you want or the way that it applies for your different services. And we will see just like a simple example over here on the quick start. I actually selected Python as a language because I believe we are familiar with this language, or at least it's kind of like easier to understand for the first time. So first thing, install gRPC, which is a Python model. You install it just running a pip install. Then you also need to install the gRPC tools, which is just basically here. Then this is for running the example that they are asking us to clone the repository in order to access like the different codes that we have in there. We're not going to be doing this, but feel free to do it after the stream, or if you want to do it right now, also feel free to do so. Then to run the gRPC application, you have to run both the server and the client. So just run both codes, so greeter server and greeter client, and just like that, like it's like super simple. And in case you want to update like your server, this is kind of like how the basics of the configuration file looks. So this basically says that that the gRPC service is defined using protocol buffers, and they are defined with a .proto file. This is just basically a .proto file that it's sending a greeting, and it is asking like what the request will have and what the response message will have. So the first step, you need to define your .proto file, which is a configuration file. And then you can actually you can generate the gRPC code running this command line code that it's over here. So once you define your .proto file, you go ahead and run this command, and that command will generate you 2 files that will be basically auto-generated once you run that command. And now you can go ahead and create your server code and your client code, which are these ones. And this one will basically have the definitions that you need or that you wanted to have. And then again, to run it, you just run the server and the client in different terminals, and they will be able to connect between each other. So going back to a little recap about how to use gRPC. So your first step, you need to define your proto file, which is kind of like a configuration file that tells how your application will behave. Then you need to run this command in order to generate some automatic configuration files that will be needed by your application. And then finally, you need to create your server code and your client code. And finally, you can run them just by running the scripts on different terminals as well. So I shared this link with you in case you want to actually run this code on your code editor of your choice to see how it actually interacts. Yes. Okay, so now to see this in a more kind of like real life example, I will share with you another link towards a code that I created about 1 week ago. And I will give you like all of the concept about how it works because I actually understand how that works. So there it is. And let me also open that GitHub link over here. Awesome. So in here is all of the necessary code for doing a gRPC API that uses gRPC. So the first thing that I did here, and for context, I'm using a package called Moondream, and Moondream is just basically a tool that allows you to do real-time image classification. That I'm actually going to do a stream about this API later at night. So in a few hours. Wait, what? Is this for real? Like they updated all of their, oh my god. I'm sorry, I'm actually like so surprised because they updated like their whole web page. Like this didn't look like this like 1 week ago. And that's why I think this tool is like super cool, which is called Moondream. And Moondream basically allows you, let's see the playground. It actually allows you to identify like things like on an image, like for example, fries. And it like gives you like the bounding box like for the fries. Like over here, like detect eggs. And it like detects like the eggs over here. So they changed like their whole documentation, and now they actually have their own server. Wow, I need to tell. This is amazing. Yes, this is a super new tool, and we will be learning about this tool on the stream that I have later on tonight in case you want to join, because this is also, it can also be used as an API. Great, but that's not the point. Let's focus. So now that you know what Moondream is just basically an API. So I wanted to use Moondream API in order to connect to our robot. So our robot basically has a camera, and the camera, it's a service. So the camera basically publishes frames of the images that it's seeing on real time. So I have that server of my camera, and then I have the other service that is my Moondream, and I want them to connect between each other in order to receive the images. And then I have another service that is a YOLO model that detects person. Why? Because I want to detect a person using the camera. I run a YOLO model to detect that it is a person, and then I use a Moondream to describe the clothing that the person is using. So I mentioned three different services. And now the question is, how do I connect them all in order for them to be talking to each other? So the solution was to use a gRPC API in order to connect all of our services. So the first step that I had to do is to create a simple .py Python class that has, nothing more than just like the methods that my Moondream library will have. And then I had to create this Moondream proto. So this is the configuration file that I mentioned. So over here I have my Moondream service, and then I'm telling it like I will have image requests. I will also have an encoded image response. I will have a find beverage request, beverage position response, and query request and query response. So I'm basically telling it all of the information that I will be requesting and the information that I will be retrieving as well. So I coded this configuration file, and then after that, I ran the command that was on the documentation on my terminal, and that command basically generated these two files automatically. So these two files were automatically generated by the command that I ran on my terminal. And then as a last step, I have to set up my client. I'm on my server. So first, going into the client, you're basically it is all commented. So in here, I had to pass on these options, as the size of the image that I was passing on was too big for the server to handle. So I had to decrease like the quality of the image. And then over here, I'm just like using the methods from my Moondream class. And this is just basically the client. And then we have the server, which is this one. And the server is very similar to the Moondream leaf in a way, because I have like all of my methods in here, and I'm just basically over here importing the Moondream library that I created earlier. But now I'm actually passing this into a server function. Oh yes, so this was I would say this was hard at the beginning, but it is helpful. And now you're actually seeing like an example of how connecting like multiple services that we wanted them to like talk to each other. This is just a way of how you would actually use like gRPC to do something and to actually make it work. I also shared like the GitHub code to our repository for like that robot. So context, that robot, it's basically a robot that it's like a butler for your house. So it's like a giant robot that is kind of like my height, and it uses like an X arm, which is like a robotic arm that actually like grabs food and like brings it to you and like detects guests, and it does like a lot of things, a lot of chores like from your home. That's why the repository it's called home. But yes, going back into what gRPC is. So as a wrap up about gRPC, it's basically to connect backend to backend applications, as we just saw on our examples that I presented on screen. I'm not going to lie to you, this one is actually harder to understand and harder to implement. It requires more understanding about APIs and client or server configurations and how they all interact with each other. But don't worry. I mean, today you were able to learn like the 4 different types of APIs. There are more types of APIs, but those 4 are actually kind of like the most common ones, or at least the ones that I've seen the most. And we can actually see like a comparison in between all of those, like GraphQL, like REST API, gRPC, and also WebSockets as well. If you hadn't used gRPC for your project, what would have been the alternatives, WebSockets, other? So we actually had the reason why we went with gRPC is because the original implementation was not working. So we were using this Moondream tool that I mentioned earlier. And the thing with that Moondream tool is that all of the things that we run in our robot need to be local. So we cannot access the internet. And to use an API, like the REST API, you need access to internet. So what we did is that we actually downloaded the Moondream model, and then we needed sort of like local communication. And gRPC allows us to connect in between our client or server locally without needing to connect like to an internet API, as for example the REST API. But I would say this is a super specific case scenario for hardware applications. But for example, if you see like the Moondream documentation of the package that we were using, it actually allows you to have like your like to interface with it using like REST APIs without the need to having like a local server. So that's just the reason why we went with the gRPC implementation. Great. So as a wrap up, here is just basically a comparison between the four different APIs that we saw today. So we have the first one, which is a REST API. You basically have a request and a response. It is most commonly used in the web, and its applications are to connecting or reading data from a database. Then we have GraphQL, which is also a request response, but it's rather called like POST. And this is for specific use cases where you want to define the requirements and the body of the response that you will be getting, which is similar to REST API, just that you are defining the information that you want to get on your response. Then we have WebSocket, which is over here, and WebSocket is just basically for real-time bi-directional communication. For example, for Google Docs or for chat applications, or the AI agent voice chat that we saw earlier for ChatGPT. That's also in there. Then we have gRPC, and gRPC was our last one that we saw. And this one allows you to create and connect like different services in a microservices architecture. So for more professional interactions or local interactions, you can use and define your own client and server code using gRPC protocol. Awesome. So I think that's all on my end. I will go back to the beginning. Yes. So if we go back to what we were learning, so I think we were able to cover like all of the important topics today, such as like REST API, GraphQL, WebSockets, and gRPCs, because I'm actually really happy that we were able to cover them all. I think that will be all from my end. I really hope you enjoyed this stream as much as I did. And if you haven't checking into this stream, please remember to checking over on that link in there in order for you to get your points. And I will be seeing you again today on my next event. So I will actually tell you when those are. Let's see. So I have one at 8 p.m. CST, but that's like on my timing. So it's the one that's called your first API request for image classification. And on that one, we will be using the tool called Moondream, which is the one that I just shared with you on the example that we were seeing. So yes, thank you so much for joining. If you have any more questions or comments, you can let me know through Discord or on over here as well, or even like on the next stream that we will have. So thank you very much, and I will see you later on during the day. Bye.